All right, today we are diving headfirst into a true medical mystery, something called complex regional pain syndrome.
Okay, I want you to imagine something for a second. Let's say you sprain your wrist. You know, it's annoying, but it should heal up in a few weeks, right? Well, what if it didn't? What if instead that simple sprain triggered this cascade of excruciating, burning pain that just never went away, and in fact started to spread?
Well, for thousands of people, that scenario isn't just some hypothetical. It is their daily reality. And it's all because of a deeply perplexing condition called complex regional pain syndrome, or as we'll call it, CRPS.
So what exactly is CRPS? Well, at its core, it's a chronic pain disorder. But here's the kicker, the thing that makes it so baffling. The level of pain is just wildly, severely disproportionate to whatever injury started it all. We're talking about a kind of pain that just makes absolutely no sense for the initial event.
Now, doctors break it down into two main types. First, you've got CRPS type 1. This is the more common one, and it used to be called RSD. It's the kind that pops up without a confirmed major nerve injury, from something like a sprain or a fracture. Then there's type 2, which used to be called causalgia. This is when there is a clear, confirmed injury to a specific nerve. But here's the thing. The symptoms for both, they look remarkably similar.
And here's what's really fascinating. This isn't some new disease that just showed up. Nope. This is a medical puzzle that doctors have been trying to piece together for centuries.
The story really kicks off way back during the American Civil War. There was this physician, Silas Weir Mitchell, who started describing this really bizarre, burning pain he was seeing in soldiers. He called it causalgia. Over the next 100 years or so, it got a bunch of different names: Sudex atrophy, RSD. It wasn't until 1993 that everyone finally agreed on the name we use today, complex regional pain syndrome. And then, about a decade later, the Budapest criteria were established, which finally gave doctors a solid standard way to diagnose it.
So that whole long history just goes to show how incredibly hard CRPS has been to pin down. But now, modern research is finally starting to pull back the curtain. And what we're learning is that this isn't just a problem in one arm or one leg. It's a systemic disease, a whole cascade of malfunctions happening across the body.
In this visual here, it really illustrates the modern view perfectly. CRPS isn't caused by just one single thing. It's more like a perfect storm. It's this complex interplay between an injury, our immune system, our nervous system, and maybe even our own genetics. So let's break that down. Let's take a closer look at each of these key players.
Okay, so the first major culprit in this whole cascade is something we all have: inflammation. But in this case, it's the body's healing mechanism going completely haywire.
Think about it. After any normal injury, inflammation is a good thing, right? It's how we heal. But with CRPS, that response goes into total overdrive and the off switch seems to be broken. You get all the classic signs in the limb. It gets red, swollen, hot, and people describe it as feeling like it's literally on fire. And the science backs this up. Studies show these pro-inflammatory chemicals called cytokines just stay elevated for months, creating this awful vicious cycle where inflammation leads to pain and that pain fuels even more inflammation.
All right, next up we have a malfunction in the body's automatic control center, what's called the autonomic nervous system. And this is what's responsible for some of the really strange symptoms you see with CRPS.
So, early on, in what they call the warm phase, that runaway inflammation causes blood vessels to open up wide. That's why the limb gets hot and red. But then, as the condition digs in and becomes chronic, something flips. The sympathetic nervous system just goes haywire, and it does the opposite. It causes the blood vessels to clamp down hard. And the result? The limb becomes cold, clammy, and can even turn this awful purplish-blue color.
But here's where it gets even more fascinating. Perhaps the most groundbreaking discovery in recent years points to a third culprit: autoimmunity. The idea that the body is, in fact, attacking itself.
And the evidence here is incredibly compelling. Researchers started finding these specific autoantibodies. You can think of them as rogue immune system soldiers in a high percentage of CRPS patients. But here's the real clincher. When scientists took those autoantibodies from human patients and transferred them into mice, the mice started developing CRPS-like symptoms. I mean, that is a huge, powerful indicator that CRPS is, at least in part, an autoimmune disease.
And, just like we see with a lot of other autoimmune conditions, CRPS isn't random. It shows a really clear demographic pattern. It's estimated to be nearly 4 times more common in women than it is in men. It just adds another fascinating, complex layer to this whole puzzle.
Okay, so you've got all this chaos happening down in the body. The inflammation, the nerve dysfunction, the autoimmune attack, but it doesn't just stay there. All of that chaos sends a constant, non-stop barrage of pain signals up to the brain. And over time, that relentless signaling can actually start to physically remap the brain itself.
You know, we usually talk about neuroplasticity, the brain's incredible ability to reorganize and adapt, as a really good thing. But in CRPS, that amazing process goes horribly wrong. Instead of adapting in a helpful way, the brain starts to reinforce the pain pathways. It essentially learns how to be in pain more efficiently.
And I want to be clear, this isn't just some abstract theory. We can actually see it on brain scans. The map of the affected limb in the brain, it literally shrinks. It gets distorted and smudged. We've even seen patients lose gray matter in the parts of the brain that process pain. This can lead to this really bizarre, distressing feeling where the limb doesn't even feel like it's part of their own body anymore. And these brain changes, they directly correlate to the intensity of the pain the person is feeling.
This connection between the brain and the pain becomes so incredibly strong that, and this is just wild, for some people with CRPS, the mere act of thinking about moving the painful limb is enough to trigger a full-blown episode of agonizing pain. That's just how deeply this rewiring can take hold.
So, where does all of this leave us? We've got out-of-control inflammation, a haywire nervous system, an immune system that's attacking itself, and a brain that has literally rewired itself to feel pain. By putting all of these pieces together, we're finally starting to solve the enigma of CRPS.
And if there's one thing to take away from all of this, it's this. CRPS is not all in your head. It is absolutely not. For decades, so many patients were dismissed, told their pain wasn't real because it just didn't make sense. But we now know, without a doubt, that it is a real, measurable, and deeply complex biological syndrome that involves multiple systems throughout the entire body. So let's just sum it all up. CRPS is a multi-system disorder. It's driven by this cascade of interactions between our nerves and our immune system. And look, understanding all these mechanisms isn't just some academic exercise. It is the absolute first step toward developing effective treatments that can finally target the inflammation, correct the autoimmune response, and maybe even help the brain unlearn the very pain it's been taught to feel.
And that leaves us with one last really big question to think about. As we learn more and more, and as we can literally see that chronic pain can physically rewire our brains, how does that change everything? How must we change our entire approach to treating not just CRPS, but all forms of chronic pain? It's a huge question and one worth thinking about. Thanks for joining me for this one.